grade 10s. Today we're going to look at one of the typical problems that you guys will encounter in your test and examinations. So let's just jump straight into it. We are given a transverse wave and we're told that it's moving across the page from left to right, and this wave has a speed of 0.4 meters per second and a frequency of 0.5 hertz. And remember, we identified that this just mainly describes the wave itself, the frequency, the speed, also the energy, the wavelength. These are just some of the parameters that will describe your wave. So I think it's safe to move to questions. Oh, before, we are told that A, B, C, and D, and E represents points on the wave, as we can see. So let's just move to the questions. So they say that write down the amplitude of the wave in meters. And so we identified that the amplitude is basically the distance between the rest, this is the rest position, and the maximum or minimum point of the wave. So from here to there, that's R, that's another R. So here we can see that we've already been given the distance in that case. We're just supposed to represent it in meters. So the amplitude in meters will be equals to 40 centimeters. But we know that centimeters is 10 to the power negative 2 meters. So therefore in meters, 40 times 10 to the power negative 2 meters is equals to 0.4 meters. Pretty straightforward. Not a lot of brain power was used in solving this problem. Just simply knowing what an amplitude is and just identifying it there and just saying, okay, from 0, that's the rest position, to 40 centimeters. That's just it. So 6.2 says label the points marked D and E. So we said that the maximum point, which is the same, E, is the maximum point of the wave. Just say 6.2.1. 6.2. You can see maximum point, we labeled it as the crest, and D, the minimum point, we said is what? Trough. These are just some of the parameters which describe a wave. Minimum point is the trough and the maximum point is a crest. So just recall at this point. Okay, I think we can move on to the other questions. So here they say that we should write down 2 points on the graph above that are in phase. And from here we can see that our A and our C, which is basically just we can see that those points are in line. And we said that in phase means that the points are supposed to be on one line, right? So A and C, 6.3. We're on 6.4. 6.4, they say how many waves are represented in the diagram, right? And remember that a wave, for us to know, okay, where's the wave, or okay, this is a wave, for us to identify a wave, it needs to complete one cycle, right? So it needs to start, then end, start, then end. So here, it's easy for us to see, okay, it's starting from 0. So from here to there, that's just one cycle, which basically describes just one wave. Okay, then again, it just goes again from maximum, minimum, and it needs to complete that. That's 2. Then from here, we can see that it ends somewhere, which is half of the wave. It's supposed to go on, but here we can see that it's 1, 2.5 a wave. So this is just 2.5 waves. And then 6.5 guys. We're almost done. Just bear with me. We're almost done. Calculate the wavelength of the wave. Right? What is the wavelength? Going back again, we just keep drilling this in, guys. Keep drilling this in so that you guys can remember, okay, this is a wavelength. Wavelength is the distance between two consecutive points that are in phase. right? But then again, we've been given something very powerful. We've been given the speed and the frequency. And so we know that the equation for speed is v is equals to f times that. And so we can just interchange those values. V is the frequency. Okay, cool. Now it's easier now. Now we don't have to really crack our heads. Just plug and play 0.4 and the frequency is 0.5. So now what we have is 0.8 what? Meters. Not cats, apples, or dogs, meters. Because it's the distance. Simple, straightforward, just utilizing the equation that you guys will be given. In 6.6, the last question, they say determine the distance and the diagram. And we can use this. I don't know if you know this, remember this? Speed, distance, time, triangle. So here is the distance, and here's the speed, and here's the time. Because we have the speed, we also do have the time, right? And remember from this we said that the speed is basically equals to the distance all over the time. That's d, that's t, and that's s. Therefore what we have is we can just interchange to find out distance. So that's speed times time. And what is our time? It's from 0 to 5 because that's how much is covered. That's the distance, right? That's from there to there. So that's 5. So the speed now, we have the speed, which we're told was 0.4 times 5. It's equals to 2 meters. Pretty straightforward. And it's just, you know, these questions are not really that challenging. It's just knowing the definitions, knowing how to play around with them, knowing, okay, what is a wavelength and amplitude, and just, you know, using a couple of brain power here and there, but more or less the questions are very straightforward. So please guys, practice. I know we didn't really go through much, but you have to just practice. That's the only way in which you're gonna get this. You just have to practice. Go back to these videos, keep rewatching them as much as you can, and yes, leave a comment if there's any mistake or issue that you found. And yeah, see you in the next part where we'll be talking about longitudinal waves, and we'll be continuing from there and going to sound waves and the other waves, which are EM waves. Thank you so much and have a nice day.